Don't believe it or not, there are professors out there that do that. It's like weak. Okay, number 20. 3.6, number 20. And I'm going to write it on the board. 3.6, number 20. And you're going to write it on your paper. And that means take the derivative of it, dx. They put a bracket around it, which I hate, it just gets in the way, but it's mathematically correct. 2x minus 9 to the second, parentheses, x cubed plus 4x minus 5 to the third. Now, in order to get you started on this, try to help you see what's going on at the beginning, I am going to put a big dot right here for multiplication. It's a product rule. But when you take the derivative of the first, you will have to use the what? Power rule. Yeah, exponent power rule. Right. Okay, see if you can get the derivative right. For those of you that are viewing this on video, this is your time to try it too. You know, the ones that are, there you go. So we got to do that. All right, just for all the students. See if you can do the product rule to that one. Do the product rule. Be very careful with your powers, all that kind of stuff. And then I'm going to give you a few minutes and I'm going to write it down on the board with the product rule if you can check your work.
You want us to do the product rule and just leave the exponents for now?
Oh no, you do it. When you do a derivative, you do the whole line. We don't do parts of a derivative like, you don't do that. We're not weak.
Of course.
That's for the chumps that can't do it. That will confuse the fool out of you if you try to do part of a derivative in one step and then some more in the next step. And I'll even give you a little more help. Call this F, call this G. The derivative is going to be F prime times G plus F times what? G prime. And when you take the derivative of the F, you're going to have to use a power rule. And when you get down here and take the derivative of the G, you're going to have to use a what? Power rule. Mr. Natterville, I don't see you scribbling away. Have you factored it?
Yeah.
Oh, okay, good. Anyone? How many people have the derivative? Have the derivatives? Okay. Well, I'll write it. This way you can check it and see if we got it right. Okay. Minus 9 times another 2. Don't forget to always take the derivative of the part that's in parentheses. The du has to be out there. And write down the second term. And then plus, write down the first term. And if you say, Mr. Evans, you can write that in a different order. Don't you dare. Is that a minus? Okay, I did write that down. And that's why with 2 above it, a little square. Then I have to take the derivative of that, and we'll fit it right in here, which is going to be 3x squared plus 4. Big on the video, can't read it. All right, how many people got the derivative right? Now, if I ask you what is the slope at x equals 1, do y'all all just agree to just put x equals 1 in there and work it?
Mm-hmm.
Is that cool? Yeah, just put x equals 1 in there and work it.
When you say that, what do you mean the slope of what?
Slope of the tangent line.
So whenever
The derivative, say this. The derivative, everyone, the derivative
the derivative
finds an equation
finds an equation
that will find the slopes
that will find the slopes
of tangent lines.
of tangent lines.
So if you put x equals 1 in there, you're finding the slope of the line touching this at x equals 1.
Okay.
If you put 2 in there, you're finding the slope of the line that would touch this at x equals 2.
So then there's more than one?
Okay, the slope's not going to be the same at all the different numbers, is it?
No.
Yeah, so yeah, you get multiple slopes according to what x value you put in.
Okay.
Right, because the rate of change is not constant. Which, the whole catch with calculus is, back in the beginning of it, they had these guys, and they kept looking around at things that were happening around them, and the planet that they were looking at moved from here to here, and then it was supposed to move, keep listening, move from here to there again, and all of a sudden it moved a lot more than it was supposed to, because its velocity was not constant. All right? And they realized also when they dropped the ball, it did not go the same speed all the way down, did it? Well, see, the formulas that deal with all that are from calculus because the rates of change in most of nature are not constant. Yeah, the rates of change in nature are not constant. And so the two guys that came up with it all, y'all know one of them's name.
Newton.
Yeah, Newton's one of the guys that came up with it. Is he the only guy? No, because the way I asked the question. And the important thing is that you also know who the other person is.
Leithold,
Whoa, who taught you that?
Yeah, how do you know that?
Mr. Allgood.
Yeah. And I don't know if it has the on the end or not. See, that's kind of scary. I probably ought to look it up. It doesn't? Linnaeus. And what Linnaeus happened, here's what happened, is they both came up with it without communicating with each other. It's not like today where they could communicate all the time and know this stuff. But they compared notes later, or their followers did, and found out that they both had come up with a way to do it. And we use a lot of his terminology and a lot of his terminology. And later on we're going to talk about Linnaeus' rule. That's in that's in integral calculus. It's how to take the derivative of an integral in Linnaeus' rule. But those are the two guys. Yes, ma'am?
Isn't there supposed to be a 3 on the second term in the power? The power of, nope, to the left, yep.
Sure is. Supposed to be a 3 right there. That's brave child correcting me, but it made me look good. See, I'd hate to have it on. You know, when these people from other schools and all this look at these videos, they're going to go, how can they have a teacher that makes that many mistakes? Yeah, sure. It's all right. Now, here we go. So, sorry about that. I had to teach you a little bit there. Hit a plus sign. Hit a bracket. Now, in the bracket over here, line up the plus signs. Start with the parentheses bits first. Don't start with the little stuff. 2x minus 9. You've always factored out to which power?
The lowest.
And so we got a 1 here, and we got a 2 over there, so we'll factor it out to the power of 1. So that one completely factors out. And this one factors out and leaves a power of 1. And that's what we want those parentheses left with power of 1. Now, look at your x cubed plus 4x minus 5. What power of it are you going to factor out?
1.
2.
What? Oh, I didn't write down the 2.
See? And then, well, you know what would have helped you though? Here's how you would have caught that. If you did factor it out to the power of 1, this would still have a square above it, right?
Right.
And instantly tells you to go back and start looking for your mistake.
Okay.
Because it should always come out to be a 1. All right? So if that were to happen, look for your mistake. All right? Then you worry about all this little stuff. And I see a 2 and a 2 here, but I don't see any place over there I can take out a 2, do you? So I'm just going to write a 4 here. Then I look over here, and I still have a 3, and I still have this little part out here, right? So we'll do that. Make 3, parentheses, 3x squared plus 4. Now, you simplify what's inside the parentheses, and you're done. And I don't need to simplify what's in the parentheses for you because you can multiply that out and FOIL it and all that. Is that cool? Yeah. Ma'am? Ask your question.
I thought you didn't like the word FOIL. I thought.
Oh, gosh, I'm sorry I cussed in here.
I know, it's the F word, you gotta be careful.
Man, I gotta be careful, I'm gonna get fired for cussing.
Yeah.
All right, now, what number did I just work, number 20?
Can you do number 9?
Number 9. Yes, I will. Number 9.
Yeah, number 9 got me.
3.6, number 9. We're ready for it? 3.6, number 9. Okay. 3.6, number 9. I'll be glad to do that one for you. 3.6, number 9. Number 9. Number 9. Y'all haven't watched the Woodstock concert tapes or big get-together tapes because while they're singing, they're also testing the system early on. A bunch of hippies out there living off of their parents' money. -3 sine 4x. Okay, now, this one, you're going to take the derivative of this, and then you're going to take the derivative of this because they're separated by a minus sign, so you can do each one of them separately, right? You do not have to use the product rule here because there is what in front? Constant. So, here we go. F prime of x equals, write down the 4. And what is the derivative of cosine u? The derivative of cosine u is negative sine u. And then what do you have to put out there on the end?
du.
The 3. And that's what everyone forgets. Now, I would have probably, if I were not teaching this to you, I'd just move the -4 right where? I'm the negative where? Right there, right? But I want you to see. That's what I'm going to do on the next step.
So with constants, you just leave them there?
They have to stay there.
Okay.
But you don't have to use the product rule.
Okay. Yeah, because if you use the product rule, it would disappear.
That's right. One step would be a 0. That's right. Minus, then write down your 3. And then what's the derivative of sine 4x? Cosine 4x. Times, don't forget that 4. And I almost forgot the 4 that time. Now, and notice we do not do the derivatives of parts of it. We do the derivative of the whole thing. F prime of x equals -12 sine 3x minus 12 cosine 4x. I know I'm going to factor out a -12, right?
Yep.
Okay. F prime of x equals -12 sine 3x minus cosine 4x. Now, honestly, yes ma'am, it would be a plus. See, taking care of it. I keep looking at the sine 3x and the cosine 4x, and I would leave it right there. Okay? I wouldn't change it. But there is a weird identity that I have never used, and I don't plan on using it on this one, that you can probably combine that. There's probably a weird identity that combines that. Okay? And if you have your trig sheet, it might even be on the back of your trig sheet. Because I gave them to you. Remember, if you were in my class, I told you I had the ones that Mr. Goebel liked. This is one of the ones that Mr. Goebel likes. Because if I did it, I would have to use a lot of rules, and it would take me like 7 or 8 steps. But there's a rule that tells you if you have sine, yeah, and I gave them to you as the Goebel rules.
Yeah.
Wait, so when we turn stuff in for you, do you want us to can we leave it like that, or do we have to?
Yeah, that's good.
So like,
Why do I have y'all trying to get to what's in the back of the book right now, though?
so you can check and make sure you did it right.
And also what?
Because that's what the
Crush the weak.
Because Leithold is God.
Okay, I like that answer.
Thank you.
No, the real reason is because I'm forcing you to go back and learn your trig rules and your algebra. See? Because let's be honest, the derivative is not the hardest part of the problems that we've worked today, is it? It's all the algebra or trig that occurs afterwards. Okay, I got to look down at the bottom and see what he did for his. I just worked number 9, right? And I'll scroll down and say, well, it doesn't look. Yeah, he just left it right there too. He stopped right there. He didn't come up with any cool rules to put it together. If Leithold didn't come up with a cool rule to put together, I'm not. Okay, so from 3-6, I have now worked 2 problems. I've worked what? 3-6, number 20, 20, number 20, and then I just did which one? Number 9. Okay. Now, anything else from 3-6, or you want to drop down to 3-7?
Can we do, number 28?
28. He sees that it's circled, so he wants to work that one, okay? We'll do 28. It's a big old quotient rule, but then it's also got what when you take the derivative of the numerator?
The product rule.
Product rule, yeah. So it's multiple levels of
Great choice, David.
yeah. And I'm not sure why I circled that, because I know I didn't want to work it. Maybe I circled it like I will never do this problem. All right, 3.6, number 28. 3.6, 28. All right. If y'all don't mind, I'm going to take the derivative straight up here on the board. Is that all right? Just save me one step of writing. I'm going to put the derivative up here. Okay with that? It's probably going to be a bad mistake. All right. I write the denominator down, 3x squared plus 5, and it's squared already, right? But what am I going to do? I'm going to square it again. So that's going to give me a power of what right there? Power of 4. Okay, because it's already squared in the original, and then I squared it. Then, I'm going to write the denominator down. 3x squared plus 5, and don't forget the square that's with it. See, it's already squared, and you're going to square it again. So the original is that. Say 3x squared plus the denominator. And now you're going to take the derivative of the numerator. When you take the derivative of the numerator, you realize that you're going to have a plus sign in there, right? You're going to have 2 parts. So it's going to be this times both of those parts. It's going to be distributed. So make sure you start off with a set of parentheses or brackets. Take the derivative of the first part of the numerator. 3, 4x minus 1 squared times 4. Don't forget the derivative of the part that's in the parentheses. Then you have to write the second part of that down. X squared plus 2 to the 4th. Plus, then you have to write down the first part. 4x minus 1 cubed. Then you have to take the derivative of that second part, which is going to be 4 x squared plus 2 to the 3rd times 2x. Okay, now we're not done, because really all we've done, here's our denominator, here's our derivative of the numerator, which is all of that is the derivative of the numerator, right? So then we have to do what? A minus sign.
Oh.
And then we have to write our what? Numerator and our derivative of the denominator.
Oh, gosh.
But the catch is, you just take your time. Don't lose any of the little cues. Now do you see why I'm telling you got to write really neat? Or, yeah, this is when you turn the page sideways. Okay, yeah, this is when you do your calculus, turn your page sideways. Minus, numerator,
Like, do it like long ones.
Yep.
So it can go in the way
Oh,
numerator, 4x
Hmm.
minus 1. Yeah, you're the one that asked about this problem. Cubed and x squared plus 2 to the 4th. And then you take the derivative of the denominator, which is pretty easy, 2. 3x squared plus,
wait, so you don't do the square, oh, no, no you don't, sorry.
all right, and then what? 6x. Okay, I'm going to double check that. Brought the 2 to the front, 3x squared plus 5 to the first, then I take the derivative of that is what? 6x. So there's your numerator, and there's your,
It was so fat.
there you go. I hate to tell y'all, this problem is not as bad as it's going to get. Actually, the other stuff's more fun though, because this is just kind of deal with a lot of little bits and pieces. Okay. If I got to this point, I got to debate how I would simplify it. But what I'm thinking now, remember, it's this times all of that product rule, right? Well, we know how to factor that product rule, don't we? So what I would do, instead of maybe putting this in there, of course you could do that. You could take this, put it in here, take it and what? Put it in there, right? But I don't like that because I just, that's not normal to me. I always, when I see this product rule here, the first thing I think is to do what to it? Factor it. And what I'm hoping will happen is when I factor it out, I can figure out something else to do. Don't try to do too many steps at once. So, what we're going to do is we're going to write our 3x squared plus 5 squared in front. We're going to line up our plus sign. We're going to put us a bracket because we're hoping not much is left. I've got to put my plus sign. And I'm going to factor bits and pieces of this out here. And I'm still trying to line up my plus sign to make it easy on me. Ooh, 4x minus 1. What power can I factor 4x minus 1 out?
Squared.
Yeah, squared. Gone. 4x minus 1. Ooh, x plus 2 squared. What power?
The third.
Third. I'll move my bracket over. I may even have to move over my line. Third. Move my plus sign over. Don't like doing that, but I'm going to. Okay, what's already left over here? 4x minus 1. Now, when I take out the x squared plus 2 cubed, this one divided out, but this one was, there's one power of that left, right? Okay? It's going to be in front of the plus sign. Now, oh, check this out. I have a 4 here, and I have a what here? 4. And that's going to leave a 3. There's my 3. And it's going to leave a what out here? A 2x. And that is still got minus all this. Yeah, but this is not pretty.
No, I'm talking about my sheet of paper. You're doing great.
Oh, no. All right. And I want to go ahead and just simplify this down right here. Just go ahead and get that simplified down. Kind of bothering me to do it, but that's what I'm going to do because I know how to do it. Do what you know how to do. Okay. When people that have worked a lot of math do problems, and y'all ask me a problem that I hadn't worked in 10 or 20 years, or a problem, you know, somebody even asked me something I hadn't seen or ever worked, I look at what I know how to do. I look at the problem and go, well, what do I know how to do? Well, I know how to factor that. I know how to simplify that, okay? The problem you guys get into is y'all look at it and go, well, I don't know how to do that. Well, yeah, you don't know how to do the whole thing at once. You got to do what? Little pieces. And this may be the first math class where you've had to do that, or tried to make you do that last year in pre-cal. But you know, it's the first time you've got to look and just say, what do I know how to do? Do that part. All right. I'll write down my 4 in the front. Oh, y'all do know there's a big denominator under there, right? Okay, I'm going to leave it off for a few minutes. I'm not supposed to do that, but I am. Okay, so I've got 4, 3x squared plus 5 squared, 4x minus 1 squared, x squared plus 2 cubed, and then everything in the brackets I'm going to simplify down. It's going to be 3x squared, and 8x squared is going to be 11x squared. And then I'm going to have minus 2x plus 6. All right? And that's just distributive property and collecting like terms, and it looks good to me. I'm double checking it because I'd hate to make a mistake now. Okay? Minus, and I'm going to go ahead over here, and normally I wouldn't do this, but I'm going to go ahead and put 2 times 6 is what? 12x. And then I'm going to write down everything else. 4x minus 1 cubed, x squared plus 2 to the 4, and 3x squared plus 5. And I am looking to make sure that does not have a power above it, because that kind of scared me. Okay. Now I've got all of these multiplied together minus each one of these multiplied together. I'm about to do what?
Combine like terms.
Oh, good try, but I'm going to do the opposite of that, because look what I got here.
Well,
I got that, and look what I got over here.
That.
I was gonna say that, but I thought that was wrong.
And then you got what? 4x minus 1 squared, and over there you got what? 4x
But
minus
doesn't
1
the 12x,
cubed.
wouldn't that go into it? Oh wait, these are, never mind.
Don't multiply them out. Factor it out. Notice how you got the same stuff over here as you have over here? And you got a big minus sign between them. So line up your minus signs and start seeing what you can factor out. And that's the key right there. Is you don't want, anytime before you start multiplying all this out, you want to see if you can factor anything out and get it out of the way. Make it easy. Okay. You will notice I have a 4 here, and I have a 12x there, so I can factor out a 4 to the front and just leave what? 3x. Is that okay? I'm going to put it way over here, because I know it's going to be way over here. And that's going to just leave it 3x. And I bet these brackets are not far enough apart either. Then, I'm going to factor out 3x squared plus 5 to the first power. Because that's the biggest power of it I got. I'm not biggest, what?
Smallest.
Smallest. I was just checking to see if y'all were paying attention. Which will leave a 3x squared plus 5 here. Now, then we'll factor out a 4x minus 1. And what power is it going to be factored out to?
to the second.
Okay. So this one divides out, and I've got to put one over here. Then I can factor out what? X squared
Plus 2 to the